So one of the things you're going to be faced with in section 11.3 is calculating interest on, say, a bank account or an investment. And in this example, we're investing $20,000. That's your principal. So that goes in right here. Your rate of interest is 16%. So maybe you invested in GameStop at the right time. Maybe you did it a little bit better. But the tricky thing about interest is that you're not going to put in 16 into the formula. You're going to put in 0.16. You have to write that as a decimal. If you actually put in 16, then it really would be a GameStop type investment because you'd have 1,600% interest instead of 16% interest. Big difference. T is your time in years. N is how often interest is added to your account or how often it's compounded. So if it's compounded quarterly, what does that mean that N equals?
N equals 4.
N equals 4. If it was compounded monthly, I think I saw one of the problems in there dealt with monthly, then N equals 12, and so on. The funny thing is that daily interest isn't 365. By convention, it's 360. All right, that's a different story. For us, this is something you want to do on a calculator. So let me clear this out so you can see me put it in fresh. Start out with the 20,000. Your calculator understands that if I wrote 20,000 next to a parenthesis like this, that it's being multiplied. So you don't have the times key. 1 plus, then the interest rate, which is 0.16, divided by N, which is 4, parentheses, raised to the N times T power. Now, N was 4 times T is 8. You could equally well raise this to the 32 power, and it would give you exactly the same thing. So it's just up to you. Some people, especially with these numbers, get really big. They don't want to put that in manually. They just rather let their calculator do it. So it's up to you. Let me go back here. No, not there. If I just put in a 32 up here, and let's delete that, then it should give me exactly the same thing. It's just whatever you find convenient. Now, when you put this into WebAssign, you're going to have to make sure that you round it carefully. And they're going to ask that you round it to the nearest hundredth, which makes sense because the smallest denomination that we have available in our currency is a penny, which is 100th of a dollar. So plugging this all in, A, which is your amortized value. I prefer to think of it as the amount that you get, 1 plus 0.16 over 4 to 4 times 8. We give you 70,161.1749. And like I said, you got to round that. Since this is less than a 5, we'll just keep that the same. And there you go. So, wow. You more than tripled your money. That's 3.5 times your money in 8 years. That's pretty good. Of course, you're giving yourself a whopping, 16% interest. That's pretty unlikely, with a safe investment anyways. All right, are you comfortable with that part? Einstein said that the most powerful force in the universe is compound interest. And you kind of see it at play here. But at the heart of this is an exponential function. And I showed you in my other videos some graphs of exponential functions, y equals 2 to the x. There's basically 3 features of this graph that I wanted you to know. One was that it came close to the x-axis. 2 is that it passed through this particular point in the y-intercept. And 3 is that it grows quickly, grows very quickly. Does anyone remember what that point is? What are the coordinates of it?
0, 1.
0, 1.
0, 1. Now that point is going to get shifted all around when we start looking at different functions like y equals 2 to the x minus 4 plus 3, for instance. This graph's going to get shifted. Now, one of the important features of this graph is this line. Y equals 0 is the horizontal asymptote. This graph is also going to have a horizontal asymptote. It's that this one's going to get shifted, you know, before, and I don't want to spill the beans here, but the horizontal asymptote is going to get shifted. Let's understand how this graph has been shifted compared to this one. So there's really two components, this one and this one. How is this one going to be shifted? What's this x minus 4 going to do?
Go to the right 4.
Excellent. Shift to the right by 4. And then how about this one? Someone else here.
Up by 3.
3.
Thank you. Up by 3. So that means this point is going to shift to the right by 4 and up by 3. So the new point on our graph, kind of akin to this one, should be at the point 4 and 4. To the right by 4 and up by 3. Now there's another feature of this graph that's going to be a little easier to see than it is with this one. And that is, it's got a new horizontal asymptote. If I shift this line up by 3, then I'll have the equation y equals 3 as my new horizontal asymptote. Then I'll plug in the point 4 and 4, and my new graph is going to look like this. So it was shifted to the right by 4 and up by 3, and that's my new graph. I mean, at least approximately. It's giving you a good sense of the overall shape here. Now you can double check yourself and things like that on Desmos. It's not a bad idea. But what you should understand is that this controls the horizontal shifting and this controls the vertical shifting. The horizontal shift is kind of opposite the sign. -4 is not a shift to the left, it's a shift to the right. And the vertical shift happens in the direction that this suggests. +3 is up 3, -3 would be down 3.
Are we allowed to use your handouts on the test?
That's a good question. Let me get back to you on that one. That's a good question.
I only ask because it's so much easier to see the graphing than if I'm just doing it freehand.
Yeah. Sure. Oh, you know, like the ones where I had the pre-made graph or 2 to the x?
Yeah, exactly.
Yeah, that's fine. That's fine. Although quite often, WebAssign is going to be giving you stuff like y equals 3 to the x plus 2 minus 5, stuff like that. And so my graphs are all 2 to the x. And the reason I chose 2 to the x is because it was the smallest exponential function that's easy to work with. But we can still work with this one and trying to understand its shifting and stuff like that. So any guesses? Tell you what, why don't you put it in the chat here real quick, which way you think this is shifted? So what's going to happen is that because of the +2, that's going to be shifted left by 2. and down by 5. And you guys did a good job in the chat in coming up with those numbers, left by 2 and down by 5. Let's actually see the effect on the graph. So over here, I've got the graph of y equals 3 to the x. And let me put in that special point that I like, 0, 1. Now, when you shift that point to the left by 2 and down by 4, that's going to put a new point right here. So this graph has been picked up and moved down to here. Also, the horizontal axis, the x-axis, that's your horizontal asymptote. That gets shifted down a total of 5. So instead of y equals 0, which is the x-axis, I'll now have a new graph at y equals -5. That's my horizontal asymptote. It's technically not part of the graph, but I like people paying attention to it anyways. Let's actually draw the function. It should pass through this point and get close to this line. And it does. Perfect. By the way, bonus points here. How can I figure out what the y-intercept is for this new graph?
Set x is equal to 0 and solve.
Excellent. Set x equal to 0 and solve. So 0 plus 2 is 2. 3 squared is 9. 9 minus 5 is 4. So this should pass through exactly at 0 and 4. Nice. How's that one looking? All right. So on the last exam, I had a few issues with people showing the work. Let me be really careful in stating here that when you do a problem like this, I want to see how you fill in the formula. And for something like this, you know, there's not too much work you can do. That's okay. But what I'm thinking of is getting ambitious and figuring out how to write my own questions for WebAssign. And I'd probably give an equation like this: y equals 4 to the x, say, minus 2021 plus 1974. Now, if you can get Desmos to graph that, you're probably pretty talented and you'd probably be in another course. So you can't rely on just looking at a graphing calculator, but you should know the basics of how things are shifted. And you should be able to tell, okay, this was shifted this way. So why don't you put in the chat again where you think this one was shifted? So the x minus 2021, how does that shift things? All right, maybe you prefer saying it in the chat, but someone want to say it here?
To the right.
Good, shift to the right by 2021. And then 1974, that's going to shift which way?
Up.
Up by 1974. Perfect. So even though we can't necessarily see the graph very easily unless we're pretty talented with a graphing calculator or Desmos, we know what it looks like. All right, so that's good. That's good. One last thing that I'll do here, one other translation you can make to these functions is if you were to graph y equals, say, -3 to the x instead of y equals 3 to the x. So this is kind of like putting a negative in front of us, a quadratic function, or y equals x squared and y equals -x squared. The negative is going to flip things around the x-axis. So instead of having something that opens up like this, you're going to have the mirror image to that, which is going to open down like that. So, all right, that should do it for this section. Any quick questions before I stop the recording?
I do have a quick question. This in regards to the function that you have y equals 2 to the x minus 4 plus 3, you know, the power of x minus 4 plus
Yeah,
3.
that's fine.
Okay, on the graph, does the new point become 3, 4? Is that
Oh, it's a
like,
great question. That's a great question. Yeah, I probably should have done that myself. So if we're shifting this to the right by 4, 0 plus 4 would be 4. And then shifting up by 3, that's changing the y coordinate. So 3 plus 1 is again 4. So this point, you're exactly right. That would be 4, 4.
okay, thank you.
Yeah, thank you. Okay, let me stop things here and put you in your breakout rooms.